Okay, so let's go find some t values when this curve is concave up. So remember to find the second derivative. First, you need to find the first derivative. So that's dy dt, so the derivative of y, so 2e to the 2t over the derivative of this. Okay, so I'm going to use, leave it like this. There's nothing to simplify really. Keep it in one big fraction. So now to find the second derivative, let me write it out. What I'm going to do is I'm going to take the derivative of this over the derivative of this, right? The derivative of y prime over the derivative of x again. So the derivative here gives me 3t squared. The derivative of this, I need quotient rule. So low d high minus high, and then d low, and then square the bottom, and off you go. Okay, so let me write this guy over here more. Okay, so that's my derivative of the x. Okay, this is over 1, right? So I'm going to multiply it by the reciprocal. Okay, so there's my denominator up here. So let me get rid of this and make some space here. Okay, so what this gives me is this denominator is 3t squared cubed, right? This and these two here. Okay, so let's multiply this numerator out. So I have 18t cubed plus 12t squared e to the 2t minus 18t cubed minus 12, whoops, I lost a t, t e to the 2t. All right, so look at that. Those 18 t squareds, t cubes go away. And then I've got these two terms on the top that have a lot in common. So I'm going to factor out a 12t e to the 2t out of these two terms. So factoring this out of this term here leaves me with a t. Factoring this out of this term leaves me with a 1. And on the denominator, if I was to cube this, I would get 27t to the 6th power. Okay, so that's my second derivative. So what am I trying to do again? I'm trying to find out when it's concave up. So I want this to be positive. So good news, no matter what t value I plug in here, it's going to be positive, right? So I'm taking it to the 6th power. As long as t is bigger than 0, this is going to be positive. And I've got this t minus 1. So in order for this quantity to be positive, that means it'll be concave up, t has to be bigger than 0, and t has to be bigger than 1. So that means use t's bigger than 1. That's when the curve is concave up. All right, let's go try another one. So here they want when it's concave down, and they're just giving me between 0 and 2 pi. Okay, so let's go find y prime. So dy dt over dx dt. Okay, so to find the second derivative. So let's just go ahead and write that as negative cotangent of t. So the second derivative is to take the derivative of the first derivative and put it over the derivative of x again, right? So the derivative of negative cotangent would be a positive cosecant squared of t, and the derivative here would give me a negative sine of t. So these are sines and these are sines, so let's put them all together in the denominator. So I get negative 1 over sine cubed. Okay, so I want this to be less than 0. Well, it's already negative, so what I want is I want when the sine of t is going to be positive. Because as long as the sine is positive, then this negative will make it less than 0. So when is it between 0 and 2 pi that the sine graph is positive? That's going to be between 0 and pi.